Okay, so what we're going to have a look at here is residual analysis. In a residual analysis, what we're looking at is a term called the residual. Okay, and this is defined as the difference between the actual value and the predicted one by the we predict from the regression line. Okay, and sort of just to put that in perspective, that is this. We go residual equals actual value minus predicted value. Okay, so here's in this example we've provided you with here. We've got this regression line here, y equals negative 2.1x plus 54.8. Now, the coordinates of the actual point are 6 and 35. So 6 and 35. So this one here is the actual point. Okay? And the coordinates for the predicted point are, so I'd put, in this case, I'd put in 6 here and go negative 2.1 times 6 plus 54.8. I'd get a number. What that number is 42.2. Okay, so this here is your predicted. And you notice that when I say predicted, it's actually on the regression line. Okay, so residuals looking sort of where your predicted value is relative to the actual, and it sort of, it looks above and below that line. Okay, and so, in this case, the residual is going to be negative 7.2 because you can see it's actually below the line. Below the line, it's going to give you a negative number. Above the line, it's going to give you a positive number. So you need to know how to actually calculate that residual. So you've got, what you've got, you've done all your analysis stuff, and what you're looking for is, it says, what's the residual? You just get the actual value. You'll be given the actual value. I'll go through an example. You go through your, you get the actual value, and you subtract what the predicted is, which is what you get from the graph. Okay. And as it says there, a negative residual indicates a prediction higher than the actual value. A positive residual indicates a prediction lower than the actual value. Okay, and this is just an example of another example of what's going on here. So for country A, you can see as the examples provided, it's going to have a residual higher, so it's going to have a positive residual. Okay. And the other one's going to have, the country B is going to have a negative residual because it's below the line. Okay. And you get that because it's actual minus predicted. So if the predicted is, if the residual value is positive, that's why you're going to have a, because it's actually smaller than what the actual value was. Okay. And what this is really testing for in the end is the assumption of linearity. Okay. It's testing for the assumption of linearity. And when you do it across multiple data points, as you see in a graph like that, you do it for every one of those data points. You check in to see, what you're going to be checking is to see, is this relationship linear or not? Okay. The key point, the really key point when you're looking at this, okay, is if it's scattered, it's a linear relationship. It's a linear relationship. And if it's got a clear pattern, often curved, then the original data, you suggest the original data has a non-linear relationship. Okay. Now, here's just here's 3 examples provided, and what you're looking for here is the fact that this one's scattered. So it's scattered, there's no clear pattern. No clear pattern. Therefore, we say linear. These two on the other hand, clear pattern, therefore nonlinear. And that's the sort of information you're going to need. Okay, so here's an example. Here's an example of what I'm going to show you how you can do this on your calculator. But let's look at these instructions first. I'll put this, when I show you, I've already put the data in. That's your EV, and that's your RV, your response variable. Okay, you're going to get some data, and from that data, I can get a line of best fit, so a linear regression line, and I can get my regression stats. So those are my stats. Okay, and then once I've done that, in doing those stats, I can actually then have my regression. I can actually have my regression plotted on the same thing here, so I can see what's going on. This is really important for when you do transformations. Okay, so let's actually do this. So here's my data. Like I said, I put it in. Now I'm going to go Control I. I'm going to go Add in Data and Stats because I want to plot it. I'm going to add variable. And the variable, we had it as birth down on the X. Up here we had it as life. And you see that that's the plot. That's the plot it was shown over here, just to sort of so you can see what's going on there. Okay, what I then do is go Menu. I go Analyze. I go Regression. And then I go A plus BX. That gives me my regression line. Okay, now I can do two things here. I'm going to go Control I again. The reason I'm going to go Control I again, I want to add a calculator. And then I'm going to add in, I want to get stat results. Okay, the stat result is for what I've just plotted. That gives you your A and your B values, and your R squared and your R. And the R squared is very important when you're doing residual analysis in a transformation activity. Okay, so what you can see here, looking at that R value, this is what it fits here. We can see that there's a moderately strong negative because it's in this direction, linear relationship. This is what it's suggesting. Okay, now I would probably wait and say linear. This looks linear. I wouldn't give a definitive answer until I've looked at that regression line, but we're saying it's a moderately strong because R is negative. Oops, I'm not writing very well here. Negative 0.8. 81. Okay, so it's above negative 0.75, or below it, or in that frame and way. But it's in that strong category there, and we've got no obvious outliers. So that's you could make that sort of when it's talking about direction, form, and strength. Okay. Next step, I can go back here and see this is my data. Now I want to go Menu. I want to go Analyze again. Now I want to go Residuals. You have to, before you can do residuals, you have to have done your regression line. I've got my residuals, and now you can see that I've got my data in a residual plot. And in that residual plot, I see no clear pattern. So I would say this is linear. I would say linear because there's no clear pattern. Okay, and that's how you can do a residual analysis and taking in consideration the stuff you need to do for when you've got a transformation. You'll do transformations. Okay, thank you.